project is separated into two phases, and we have currently completed the first phase. In the first phase, we have two goals. The first goal is to provide data analysis from all the sensors and storing them on a cloud-based platform. The second goal is to provide users with mobile control over the aircon system. For data analysis, we have a total of 11 sensor data that we collect and upload to be stored on our cloud platform. These 11 sensor data include temperature, humidity, power consumption, differential pressure between the internal components of the aircon and the external environment, as well as the refrigerant pressure, and as well as 6 degrees of motion of the compressor to detect any abnormal vibrations. These 11 sensor data are all stored on our cloud platform and can be accessed from a mobile app. The mobile app also provides a mobile control that can directly control the aircon's power on or off, as well as the temperature to be increased or decreased. So this is our refrigerant pressure sensor. This is connected directly to the place where the refrigerant is stored. And this is our differential pressure, where there will be two tubes protruding from the sensor. One will be inserted inside the aircon, and one will be left connected to the external environment. This is our accelerometer, where it measures 6 degrees of motion of our compressor as it is attached here. This is our temperature sensor, where it detects the current temperature that the aircon is operating at, as well as the humidity of the air. This is our power consumption sensor, where it detects the amount of current that is currently being consumed. It will later be converted to power through a conversion in a circuit that we have constructed, as can be seen here.
For the next part, sensor data will be uploaded from the NodeMCU, an open source IoT platform, to the MQTT server. This is done by using an MQTT broker on a software known as Node-RED, which is installed in the Raspberry Pi. The MQTT broker, in our case known as the Mosquito, is installed on the same Raspberry Pi the Node-RED is running in. Okay, to begin with, the Node-RED console should be run each time we need to use the Node-RED software. Next, we just type in the IP address into the search bar. Once the step is done, an MQTT input node is added to the flow, followed by an output debug node, which displays the sensor data on the sidebar tab of the Node-RED. To save the sensor data into the Raspberry Pi, a file node is used to write the contents of the sidebar tab into a log file. 11 separate flows are built for each of our sensors, and the sensor data is parallelly added into their respective log files.
So, by having the log file being stored in the Raspberry Pi, later on, we can retrieve all the sensor data from the log file and upload it to Fable IoT using Python programming language. Fable IoT, it is a Malaysia startup IoT platform where you can store all the data streams. As you can see over here, this is a Python coding for retrieving data and sending data to Fable IoT. This is the Fable IoT data storage platform, where all the sensors data are being stored here. Later on, with Fable IoT, we can as well plot out the graph of the data with the time of it being sent to Fable IoT. We can know that at certain time, what does the data look like. For example, in the morning, the temperature of the weather is, let's say, for 27 degrees, and for tomorrow is 28 degrees. With the graph being plotted out, you can see every single day what is the temperature and what time is it.
A cloud provider called Fable IoT collects and sends data from and to the Raspberry Pi, whereby the Raspberry Pi receives data from multiple NodeMCUs connected to the air conditioner sensors. It is then connected to a hybrid mobile app known as Ionic Tree, which is compatible with Android and iOS mobile devices.
Ionic 3 is a web-based app that uses the scripts to code it. For our app, we use TypeScript as our programming language to type it. We use the Visual Studio Code as our go-to program to code the app. So for the app, we use the post request to send data to the Fable IoT. And to receive the data from Fable IoT, we use the GET request to get data from the Fable IoT.
Okay, so this is the Ionic app. There are two pages. The home page, we use it to control the air conditioners, and the detail page, we use it to see the data of the air conditioners. So from the control page, there are two controllers that we can control for two different aircons. On the aircon, inside of it, we got three selections: the power, increasing temperature, or decreased temperature. So for the details, we receive the data from Fable IoT and it will show over here. So let's try to control the air conditioner now. As I press the power on, the air conditioners will be on. And as I press the increase temperature, the temperature of the air conditioners will increase by 1 at a time. And same goes for the decreased temperature.